Dear students, now we are going to see the subject transmission lines and RF system. Under that, the topic is measurement of VSWR and wavelength. On completion of this measurement of VSWR and wavelength, the students can be able to describe the wavelength and VSWR, determine the VSWR of any transmission line. So measurement of voltage standing wave ratio, that is represented by VSWR. If the maximum voltage and minimum voltage are known, then the SWR can be calculated by using the equation. Standing wave ratio is the ratio of Vmax to V minimum. Therefore, SWR in fact is the determination of maximum and minimum voltage. So open wire line, the value of maximum and minimum voltage can be obtained by using a symbol setup as shown in figure. In an open wire in parallel, we are connecting a voltmeter to determine the maximum and minimum voltage value. Here a sliding contact AC voltmeter V is used to measure the voltage at a different point along the line by sliding the contact C1 and C2. One thing that becomes obvious is that the ratio of Vmax to V minimum becomes larger as the reflection coefficient increases. That is, if the ratio of Vmax to V minimum is 1, then there are no standing wave and the impedance of line is perfectly matched to the load. If the ratio of Vmax to V minimum is infinite, then the magnitude of reflection coefficient is 1, so that all the power is reflected. Hence, this ratio known as voltage standing wave ratio or the standing wave ratio is a measure of how well a matched transmission line is to a load. In a coaxial cable, the VSWR measurement setup is shown in figure. So, this setup consists of a signal generator, pad, and a probe or a slaughter section. The slaughter section output is given to a detector. Detector output is measured in a meter. The probe is also connected with the unit under test and it is also connected with the matched load. The slaughter line section and the probe voltmeter for SWR measurement is shown in figure. The signal source must present a matched impedance looking back into it. Otherwise, the reflection from the network being tested will reflect again off the signal generator and cause the peak and nodes to shift in proportion in the standing wave pattern. So, the figure shows the diagram of slaughter line section and probe voltmeter for SWR measurement. Directional couplers, that is mainly used for the measurement of standing wave as a device known as a directional coupler and is used in the figure. So, directional coupler with the coaxial cable is shown in this figure. Reflectometer, the advantage is the voltage on a transmission line consists of two components traveling in opposite direction. The power gain from a transmitter to load is represented by incident wave and the power gain reflected from the load is represented by a reflected voltage. So, SWR can be calculated from the following formula. SWR is equal to sum of incident and reflected voltage to the difference of incident to reflected voltage. The SWR measurement setup for the reflectometer is shown in figure. So, the meter is energized with the help of AC source. Measurement of wavelength. It is based on the fact that the distance between two successive voltage and current maxima or minima being equal to half the wavelength, that is lambda by 2. Such measurement when made on an open wire line is called lecture measurements. Resonant air insulated lines are normally used to measure the wavelength. The line is arranged with a movable short circuit. At one end is loosely coupled to the generator at the other end. When the line is adjusted to a resonant length, the energy coupled from the generator is able to build up the oscillation of large amplitude of the line. A parallel wire line used for the purpose is called lecture wire system. The resonance is determined by the reading of current indicator connected in short circuiting the slider S. A short wavelength, the preceding method is used with the coaxial cable and an instrument built especially for this purpose is called coaxial wave meter. It consists of an air-insulated coaxial line which is closed at one end and has a movable short at another end. When the coaxial meter has been adjusted to one of these lengths, the current in the coupling loop is able to build up an oscillation of large amplitude within the wave meter. So possible quiz question is, if a transmission line is terminated with resistance equal to characteristic impedance, then the standing wave ratio is minimum. Thank you.